Okay, let's run through these. 1, 2, 3, 4, 5, 6. Any questions there? 1, 2, 3, 4, 5, 6 on page 63. Questions there? You got it. 2. Number 6.
Oh.
Number 2, all you do is -3 can't work.
-3 can't work?
Yeah, that would make it 0.
Yeah, because I got it.
Cool. All right. Let's see if I can make this less blurry. Okay. So it says, for the following problems, determine all the possible values of the variable that will cause the whole thing be 0. So B and these are being multiplied. If this was 0, 0 times the quantity is 0. If this becomes 0, 0 times the quantity is 0. So if you look at this, yeah, sometimes you can't see it right away. But then you just set each of them equal to 0 and solve it. This just becomes two-step equations. So add 1, divide by 2. So if I plug 1/2 into this equation, that becomes 0. If I plug 1/2 into this one, it doesn't become 0, but 0 times something else is 0. And then this one, add 2, divide by 3. So on this one, if I plug 2/3 into this one, it becomes 0. If I plug 2/3 in this one, that's not 0, but this is 0 times something else. So that's what 1 through 6 deals with. All right? Yeah?
I wanted to say that 3x minus 2 is 3x plus 2.
Thank you. 3x plus 2 minus 2 minus 2. There we go. Perfect. That was the easy fix. Thanks for making it easy on me. Let's see. 7. Applied fundamental theorem. How many possible roots? So problem number 7, the highest exponent to the 3rd power, so there's 3 possible roots. Number 8 is highest exponent to the 4th power, so 4 possible roots. Problem number 9, it's x, so x just sitting there alone is x to the 1st, so that is 1 possible root. And then y equals -16 is a horizontal line. Remember, the horizontal line will not cross the x-axis, so none.
Is a root the same thing as solution?
Solution,
Okay.
root, where it crosses the x-axis, those are all very similar.
Wait, what was 10?
No solution because of the horizontal line. All right, 11 says apply the fundamental theorem of algebra to determine total number of roots for the function. So number 11 we count, it goes 1, 2, 3, it crosses 3 times, so 3 possible solutions. Number 12, it crosses the the x-axis once, so 1 possible solution. Number 13, 1, 2, 3, 4. 4 possible solutions.
I got 3.
For number 13?
No.
Miss, I have a question. So, for number, like number 11,
Oh, you're
12,
right,
and
you're
13.
right.
Because yesterday you actually listed the numbers. Like
I did, yeah.
But in these ones you can't see it.
Right, so you had something like this, right? So that's a solution. I would just do that. Yeah, all right. 2, 3. So those are the solutions. Even though we don't know what the exact number is, we see that it crosses the x-axis.
So will we be able to
So on a test, if I had something like that, I would just say, hey, how many real solutions does this have? You'd say, oh, it's got 4. And you'd be able to say it's got 4 because it crosses the, I'm sorry, I'm interrupting your conversation. It has 4 because I crossed the x-axis 4 times.
But we don't have to put the actual.
Sometimes if it would be a really clear graph if I asked you to find what the solution was. But if it was just something like that where you're like, hey, there, and there. Where's there? There. You don't know exactly where. Let's see. Use the zero product property to solve the equation. So let's just look at each of these. Number 14, I have x minus 4 and x, and it's equal to 0. So this means that if x is equal to 4, that would yield me the point 4 comma 0. Or if x is equal to 0, that would yield me the point 0 comma 0. That's how those solutions work. Okay? You have it, if you list it as a point, you have the understanding of that solution is where it's crossing the x-axis. And then if I go to number 15, I have x plus 1 and x minus 4. That's equal to 0. So this is going to give me x equals -1. If I plug that in, I get 0. So that gives me the point -1 comma 0. That's my solution. That's where it crosses the x-axis. This is x equals 4. So that gives me the point 4 comma 0. 4 comma 0 is where it crosses the x-axis. Then if I look at number 16, I can probably squeeze that here. 16, I have x minus 3 and 2x plus 14 equals 0. So this gives me x equals 3. So that gives me the point 3 comma 0. This one, I'll just set it equal to 0 because I can't really do it in my head. Some of you might. So subtract 14, divide by 2. So then I get negative 7 comma 0. And that's the front page.
Wait, will you count it wrong if we don't do it on
Well, if you're doing it on your homework, so make the correction. But I want you to understand what a root is. It's a point. Okay, and it's a point that has 0 as the y component. You show that, you show that you have the understanding. All right, 17, explain why the roots are not x equals 5 and x equals negative 3. Because if I plug 5 in, that gives me 0, but the whole thing's equal to 4, right? What's that? What are these equal to? 0. So if you plug the number in, it doesn't give you what it's equal to, it's not a root. Let's see, 18, 19, 20, 21. We're just double distributing. Yeah.
Why'd you put negative 7 if that's a positive 14?
Oh, when you solve it, because 2 times negative 7 is negative 14. Negative 14 plus 14 is 0. Cool. All right. 18, 19, 20, 21. I'll do 1. Any of those? Go ahead. 18 through 21. Any that you want to seek? 21. Okay. Thank you. So you got 3x minus 7 and 3x plus 5. This is just our double distribute. So here, here, and here, here. So that's 9x squared plus 15x minus 21x minus 35. I do have those like terms to combine. And we get to there. Okay? That's all it is. We've done it tons of times. 20, I only said I'd work one of these. So they're all done the exact same way. 20 would work out to be 81x squared minus 16. The middle terms fall out because you'd have the exact same but opposite sign. All right, take a look down to 22 through 32. These are just, right, the polynomials, 2 factors. Yeah. 2, 5. X to the 5th minus x to the 3rd. That's a good one. Thank you for asking for this one. Okay, so what do I have in common between the two? I have x to the 3rd, right? Because x to the 5th is x, 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 x. X to the 3rd is x, x, x. So I can factor out x to the 3rd. If I factor x to the 3rd out, I get x squared right there. Agree? If I factor x to the 3rd out of there, what do I have to put as a placeholder? 1. Is there anything special about this part right here? Yes. What is it? What is it? What's special about x squared minus 1? I'll give you a hint. This factors the x plus 5, x minus 5. Because those are both perfect squares. Those are both perfect squares. So what does this factor to?
Oh wait, x plus 1.
Good, x plus 1, x minus 1. So I get x plus 1, x minus 1. Don't forget your greatest common factor. There it is. And one more, yeah. What do you got, B?
30.
How much?
30.
30, thank you. My ears are a little clogged, so I can't hear. 30. I have x to the 3rd plus 19x squared plus 60x. Oops, I can't. So that's a 19, right?
Yeah.
Okay. All right. It looks like I have a greatest common factor of x. So then I have x squared plus 19x plus 60. Is that okay? So here's that greatest common factor. Here's our little brother coming down here. So it'll be part of the answer, right? Okay. So no other greatest common factors there. It looks like my magic number is positive 60. Agree? So I'm just factoring this part though, right? So are both signs positive, both negative, or one of each? Both positive. Why? I heard it.
Those things are both
Yeah, everything's positive up there, right? So that's our only go-to. And then let's see if we can do this in our head. What factors of 60, both being positive, add to 19? I think 4 and 15. What do you think?
Yeah.
Does that work? Did I list all the factors? No, because I kind of went through and logically thought about it. Now, is it okay to continue to list the factors? Yes. But you need to start getting to going, what's my number sense? What are factors? And if you're only able to see 1 and 60, you better have your calculator out with you. That way you can go 60 divided by 2 to see if it's factor, 60 divided by 3 to see if it's factor. Okay? So this definitely works. So I'm going to just factor this. So I get x squared plus 4x, right?
Plus 4 is
Plus 15x, good. And then plus 60. So now I'm going to take the parts. What do I have in common between these two? X. And I'm left with x plus 4, right? This sign always comes down. What can I factor out of here? 15, good. Because you're trying to get those binomials to match, right? And so my answer is x plus 4, and what do I have left? X plus 15. It's done.
Wait, wouldn't it be x squared because you have the x in green coming down plus the extra x in the red?
You can't get it.
It's not squared because I factored this out. So all I'm factoring is this. So when I factor an x out of both of those, it leaves an x behind and it leaves a 4 behind.
Oh, wait.
Okay, so this whole thing right here is the answer. Okay, I will tell you, a lot of you are forgetting the little brother at the mall. You're going to get home and mom's going to be ticked because guess who's still at the mall? You forgot little brother. Okay, keep little brother. There's a reason why I draw an arrow to here and then rewrite it. Okay, don't forget little brother. You know mom will be mad at you. You leave your kid at your little brother at the mall. And then some of you are like, I don't have a little brother. Okay. All right, if you would, please pass forward your assignments.
This is when we turn off the Monday.
Yeah, that'd be good. Thanks, man.
Sorry, why are you like that?
Three.
No.
What?
Bro, give me my phone, bro.
What? Alright, here, dude. Here. Takes out your phone is right here. Keep digging it, take it up. Somewhere.
Good. Homework is here. All right. I handed you guys too many, huh? Thanks, Brian. All right, let's take a look at this. I actually don't have these notes pulled up, but I think we should be able to handle it. So let's go to the warm-up. So go to the warm-up. We're out of here at 49. We got time, yes? Okay. So please try and work this out on your own. Please try and work this out on your own. So you need to factor the first part and then set each binomial equal. That's the warm-up, one of the warm-up problems. So try it. I'm going to just put the next couple. See if you can't figure it out.
You can kind of just imagine that you was not there, right?
What did I do? Try those first three. See if you can figure them out. Figure out those first three. Some of you are talking. Come on, figure it out. You ready? All right, item number 1. So we have an equal sign. Agree? That means we're actually trying to solve it. When we solve it, we're trying to find the solution. Okay, so this is going to be a factoring problem we do first, and then we'll set each of those binomials equal to 0 and try and solve it. Is that okay, that vocabulary I just used? Okay, so we're going to do, our magic number is, looks like -6. Agree? So that tells me my factors both have to be one of each. Okay? And so I have positive and negative. Which factors being positive and negative of 6 would give me -5? 1 and 6 or 2 and 3? Be very careful. Watch your signs. It's 1 and 6. Why is it 1 and 6 and not 2 and 3? I agree that 2 and 3 added together is -5. And this is one that catches a lot of people. If this was a positive sign right here, both signs would be negative, negative when you use the 2 and 3 all day long. Or if all 3 signs were positive, the 2 and 3 would work. But because we are alternating signs, this is the one that will work for us, having a -6 and a +1. Okay? And that's a big, we love giving this problem to you because it catches you off guard. I think we're a bunch of mean people for doing it, but hey. All right, so I have x squared plus 1x minus 6x minus 6. And it's still equal to 0. We're still going to factor what we know. That sign comes down. Still equal to 0. Notice I'm carrying that down. So I get x plus 1 and x minus 6. Those are equal to 0. Okay, it's equal to 0. So I want to know when I plug something in, what is it going to give us? So this is going to yield me x equals -1. And this is going to yield me x is equal to 6. If I make this a point, that's -1, 0. Because it's already -6. So x minus 6 equals 0. Add 6 to both sides. Okay, -1, 0 is a point. -6, 0 is a point. They are the solutions because if you plotted those points, they are sitting on the x-axis. They don't go vertical or vertical at all. Okay? Those are my answers. -1, 0, 6, 0. Do I expect you to write it that way? Yes. What if we don't write it that way? I take points off. I want your solutions. It's not a difficult concept to realize that a solution crosses the x-axis. And if it crosses the x-axis, that means that it will have a 0 in your y location of your point. Next problem. This one's pretty set up easy. This just gives me x equals 0. Oh, I'm sorry, B. That gives me x equals 5, agree? So what's this point right here?
0,
0, 0. What's this point?
5, 0.
Done. There's my solutions.
Wait, why did we have to solve the last one but not this one?
Oh, it's just this one was set up nicely for us. Okay? Next one. Yeah, I'll split screen. You good?
Yeah.
I think I can split screen it. That work? All right, let's go next one. All right, this one. Ooh, yuck. Now, take a deep breath. We can do this. If I divide every one of those things up there by 2, that means I'm kind of ignoring the greatest common factor. Agree? Right? Make sense? So I could factor out the greatest common factor, or I could just say, hey, I'm going to divide all of these by 2, including the 0. Now, because I'm not really worried about factoring out the greatest common factor, I'm trying to solve it. Okay, so I get 2x squared minus 13x plus 15 equals 0. Wait, where did the 2 go? Well, I just divided it. I divided everything by it. Right? Agree? What should I do next?
Yeah, multiply 15 times
Yeah, let's start doing our factoring. So my magic number looks like 30. It's positive 30.
Yeah.
What can you tell me about both sides? Are they both positive, both negative, or one of each?
One of each.
I'll let you re-answer that. I'm multiplying two numbers together. I get a positive number. What guarantees both sides have to be? They can be both positive, positive, or negative, negative. Which is it? Negative, negative. Why is that? Because I have a minus sign right there. All right, so what factors of 30, one being or both being negative, would get to negative 13 when we add them? Yeah. 15 and 2. Both being negative, no. Yeah. It's not prime.
Oh, wait.
Who? Yeah. 10 and 3. If those are both negative, if I add those together, I get negative 13? Absolutely. Okay, so let's factor this. I'm going to single screen now. Single display. All right, so I have 2x squared minus 3x minus 10x plus 15. It is equal to 0, but we're just going to solve this. What do I have in common there? X. Okay, 2x minus 3. The subtraction sign comes down. Factor out of here. I want it to look like that, so I'm factoring out a 5. Okay. So I'm going to get 2x minus 3. That's a 2. I'm sorry about that. And x minus 5. Those are equal to 0. So, let's see. 2x minus 3 equals 0. So add 3. Divide by 2. So that gives me the point 3 over 2 comma 0. Wait, how can you have a fraction as a point? It's a number line. And then what does this one give me? X equals positive 5, right? So 5 comma 0. So those are my solutions to the problem. Can I move on? All right. What's different about this problem now? Yeah. It equals a number. So let's make this 0. So what should I do to make that 0? What do I have to do to that negative 3? What do you think? Add it, yeah. Just add 3 to both sides. So that gives me x squared minus 4x plus 3. And I will just tell you that this is factors to this. So that gives me x minus 3 equals 0. So x equals 3. So 3 comma 0. Sorry, I didn't go through the whole factoring process with you. But that's how we do that problem. So we don't want it to equal a number that's not 0. So we have to make it 0. Okay? So what didn't I show you? I didn't show you the factoring process from here to here. But I'm pretty sure you can do it. You guys are doing really well on this quiz. Oh, by the way, by 6th period today if you need time. Right? You gotta come find me. 2nd or 3rd and 5th period I teach class, so come find me. I have your stuff. Hey, what did they? Oh, it's not equal to 0, is it? So what should I do with the 9x? Subtract it from both sides? Okay. So I get x squared minus 9x equals 0. Shoot, how do I solve that? Well, I have a greatest common factor between those, which is called x. So I get x and x minus 9. Those are equal to 0. So I just factor out a greatest common factor. So then this is going to say that x equals 0. Gives me the point 0, 0. And this is going to give me what? X equals what? 9. So that gives me the point 9 comma 0. Is that okay? Can I move on? Did I just do this one?
Yeah.
Oh. What kind of problem is this
The
one?
next one is next x squared minus 4 equals negative 3.
Oh, this is. What? Is that right, Donna?
No, 0. It's negative 3. For the third one.
You put it twice.
Oh, I had it twice. So the first and the third is. So I moved on.
Yeah, you got number 5 right now.
Yeah, okay, number 5. Number 4.
Go back another one.
Oh, there we go.
That's number 3.
That's number 4.
Number 3 I already did the same one as same as number 1.
Oh. Wow.
All right, let's take a look at this one. What should I do? Yeah. Add 4, so bring it over. So I get 2x squared minus 9x plus 4 is equal to 0, right? Is that right? Magic number looks like it's going to be 8. It's going to be positive 8. I know they both have to be negative. So 1 and 9 will be the factors at work. 2x squared minus 1x minus 9x plus 4. Huh? Oh, no, it's 1 and 8. Wait, yeah.
1 and 9.
1 and 8. 1 and 8 should be. That should be an 8x. All right, let's factor here.
Oh.
Minus sign comes down. Looks like I have 2 in common. Factor in negative out. So I get x minus 2 and 2x minus 1. Solve them. So that's 2 comma 0. Solve that. X equals 1 over 2, right? Because you'd add 1 divided by 2. So you get 1/2 comma 0. Done. May I move on? Hold no.
To the split screen.
Here to the left.
Also have to the split screen.
Oh, I could do that. Split check. That work?
That's so smart. You're gonna all
All right. Hey, x squared minus 4. How do I factor that? Not a greatest common factor. Is x squared a perfect square?
Yes.
Is 4 a perfect square?
Yes.
Is it a subtraction sign? Is this the difference of 2 squares? So this factors x plus 2, x minus 2? So my answer is x equals negative 2, so I get negative 2, 0. And x equals positive 2, that gives me 2 comma 0. Done. So recognizing the perfect squares will be helpful. What about this one? It's already equal to 0. These both have x, so let's factor an x out. X minus 3 equals 0. So this gives me x equals 0. So 0 comma 0 is the solution. This gives me x minus 3 equals 0, so x equals 3. So 3 comma 0. There's my answers. We going okay? Oh, fiddlesticks. Can I move all of this back over to that side? So if I have 3x squared, if I add 20 to both sides, I get 20x. If I subtract 32, I get this. Agree?
Yeah.
Is that okay to do? Sure. Multiply that, my magic number looks like negative 96. So then factor that. I'm not going to factor it. I'm sure you can. Okay. Is this the last problem?
There's last 3.
That's it? Yeah. So this one, oh, it looks like they both have a 6 in common. So then I get x squared plus 1 equals 0. Hey, is this a perfect square? Well, let's see. I can divide by 6, so those cancel. So I get x squared plus 1 equals 0. Is this the difference of 2 squares? Where's the subtraction sign? There isn't one. This is the addition of 2 squares. Can we solve the addition of 2 squares at this point? No. There's no solution to this at this point. It's actually no real solution if you wanted to.
At this point, do we want to learn this and then
Yeah, there's something called complex numbers that we will start getting into.
actually learn something new every day? Get the gist
Good.
of math.
All right,
Should we not have homework?
page 65, 66. Let's do this. Page 65 and 66. Let's do evens. Is
Yes.
that okay?
Yes.
Can't figure out which ones are even, do them all, and it'll guarantee you got the evens, okay?